Hi, I'm Tara, and this is an equilibrium concentration problem. So we start by adding 50 grams of N2O4 gas into a 2-liter container and letting it come to equilibrium. And that process is represented by this equation here. And the equilibrium constant for that process is equal to 0.133. And then after it's come to equilibrium, we add 5 grams of NO2 gas and let it come to equilibrium again. And then what we're trying to solve for is the final mass in grams of N2O4 after it's come to equilibrium twice. And so we're going to solve this problem using a Rice table. And the thing about concentration is it is a state function. So it doesn't actually matter even if we add these two gases separately, the final equilibrium concentration is going to be the same as if we added them at the same time. So we can solve it using one single Rice table. But before we do that, we need to find the actual concentration of each gas. And I've already set up the equation for that. So basically, for both gases, we're going to take the mass in grams of the gas and divide it by its molar mass in grams per mole, and then divide that by the volume of the container, which is 2 liters. And once we solve those out, we're going to get the molarity of N2O4 is 0.272 moles per liter. The molarity of NO2 added is 0.0543 moles per liter. And so we can use those molarities to fill out this Rice table, where basically the initial molarity is those quantities that we just found. And then as you can see in this balanced equation, for every 1 mole of N2O4 that decomposes, we get 2 moles of NO2, which means that the change in reactant is going to be negative 1x, the change in product is going to be positive 2x, and then the equilibrium concentrations are just going to be a combination of these two. So 0.272 minus x for N2O4 and 0.0543 plus 2x for NO2. And then as we know, this is like the equilibrium expression where the equilibrium constant is equal to the concentration of the product raised to their coefficient, which is 2, over the concentration of the reactants, and in this case the coefficient is 1. So if we just plug these values into this expression, we're going to find we're going to get this expression here, and then we can simplify that a little bit by multiplying this side by the denominator and squaring the numerator. And then when we do that, we're going to get this expression here, and then we can just simplify that one step further by moving all the terms to one side. And then we're going to get this expression, which is 4x squared plus 0.350x minus 0.0333 equals 0. And then we can use the quadratic formula on this equation. And so in these terms, we can see that A is 4, B is 0.350, and C is negative 0.0333. And then, as you know, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And so we just plug these quantities into that. Then we get this formula, and then we can just simplify that one step. We get this formula here where x is equal to negative 0.350 plus or minus 0.810 all over 8. And so if we solve this first by using addition in the numerator, we're going to get x is equal to 0.0575. And if we solve it using subtraction in the numerator, we're going to get x is equal to negative 0.145. And we know that this is the only possible correct value for x because if we plug it back in here, if we use this negative value, we're going to get a negative concentration for NO2, and that's not possible. So we know that this is x, and then we're going to use that to find the concentration, the equilibrium concentration of N2O4, which is equal to this expression here, 0.272 minus x, which is 0.0575. And that is equal to 0.215 moles per liter. And then to get that from molarity into actual moles, we're going to multiply it by the volume, 2 liters, and then that is equal to 0.430 moles of N2O4. And then to get that into grams, we're just going to multiply it by the molar mass of N2O4, which is 92.011 grams per 1 mole. And then once we do that, we're going to get 39.5 grams. So basically, what we did to solve this is we found, using the masses of the gases, we found the initial concentrations and then plugged that into a Rice table, and then used that and the equilibrium constant and the quadratic formula to get the final concentration of N2O4, and then converted that concentration from molarity into grams. And so the final concentration of N2O4 equals 39.5 grams.